Lesson 8, Combinations with Cases and Conditions. So a restaurant serves 10 flavors of ice cream. You order a large sundae with 3 scoops of ice cream. How many different combinations can you choose from if you want each scoop to be a different flavor? So there's 10 flavors, so n is equal to 10. We're going to choose 3. So we have 10 and 3, which is 10 factorial over 3 factorial times 10 minus 3 factorial, which is the same as 10 times 9 times 8 times 7 factorial divided by 3 times 2 times 1 times 7 factorial. The 7 factorials will cancel. 9 divided by 3 is 3, and 8 divided by 2 is 4. So we have 10 times 3 times 4. 3 times 4 is 12, times 10 is 120. So there's 120 different options if you want to choose 3 scoops from the 10 possible flavors. Now, if your favorite flavor of ice cream is strawberry, how many combinations can you make if one scoop has to be strawberry? So we have 2 events going on. We have 3 conditions going on. There's 3 possible ways we could do this. We could have it with 3 scoops of strawberry because you love strawberry so much, like me, because strawberry is my favorite. You want to get 3 scoops of it. You'd be like, oh man, I really love strawberry, but not that much. Get 2 scoops of strawberry. And the last option would be that you like strawberry, but do you really like strawberry that much? Because you're only going to get 1 scoop of strawberry in your sundae. So if you take 3 scoops of strawberry, that means you have 1 option, and it's strawberry. So you're going to take the one way to choose it, and that's if they're all strawberry. So that is equal to 1. There's also the option if there's 2 scoops. So that means that in total you have 1 for the strawberry, and there's 9 left for your remaining scoop. So for your scoop of strawberry, you're going to take 1C1. There's only one way to pick 2 types of strawberries, but there is 9 different ways to choose the last remaining scoop. So that second part is 9C1. And for the last one, for your scoop of strawberry, there's only 1. So it's 1C1. There's only one way to choose 1 scoop of strawberry. For the last one, we have 9 options again, but we're choosing 2 scoops because we still have 2 remaining scoops left. So we're going to times it by 9C2. And if you're clever, you know that 1C1 is equal to 1, so we can just cancel these out because they are the same as 1. So we have 1C1, and we're going to add all of these options together because they're all different scenarios. Do not multiply them like in here. You're multiplying them in here because this multiplies the number of options within one condition. When we have multiple conditions, such as 3 scoops, 2 scoops, and 1 scoops, you have to make sure you add these together. So we have 1C1 plus 9C1 plus 9C2. And if you type these into your calculator to make it a little bit faster, we have 1 plus 9 plus 36, which makes a grand total of 46 different options if you want to have at least 1 scoop being strawberry, because it's delicious. Example 2. Tanya is a coach of 9 players, 5 male and 4 female. In each competition, teams of 4 compete. So for A, how many different 4-person teams does Tanya have to choose from for an all-male competition? So we're only allowed to use the males here, and we need to take 5 of them and choose 4 of them. The order does not matter, so we have 5 over 4, which is 5 choose 4, which is the same as 5 factorial divided by 4 factorial times 5 minus 4 factorial, which is the same. This is a 1, so 5 factorial divided by 4 factorial times 1 factorial. This is the same as 5 times 4 factorial divided by 4 factorial. These cancel, so there are 5 possible teams that she has to choose from. Part B asks, how many 4-person teams does Tanya have to choose from with 2 males and 2 females for a mixed competition? So we have 2 males, 2 have to be male, and 2 have to be female. So because we're multiplying these two things together, because there's different options when you choose per condition, there's not multiple conditions, because we know there has to be only 2 males and only 2 females, we're going to multiply these together. So for the first one, we have a total of 5 males and we're choosing 2. And for the second one, we have a total of 4 females and we're choosing 2. So we have 5 C2 times 4 C2. If you type this into your calculator, you'll get 10 times 6, which is 60. When you don't type it in your calculator and you do it factor notation, because I like you to do that, you take 5 factorial divided by 2 factorial times 5 minus 2 factorial times 4 factorial divided by 2 factorial times 4 minus 2 factorial. This each simplifies one at a time to be 5 times 4 times 3 factorial divided by 2 factorial times 3 factorial. This will cancel. 4 divided by 2 is 2, so we have 5 times 2, which is 10. This turns into 4 times 3 times 2 factorial divided by 2 factorial times 2 factorial. The 2 cancels. 4 times divided by 2 is 2, and 2 times 3 is 6. And we already know that 10 times 6 is 60. So either way gets you to the answer. This is the way that you should do it. But the calculator works too. Remember that if it asks to show you in factorial notation, that you show it in factorial notation. So this is one that has different cases. So a planning committee is to be formed for a school-wide Earth Day program. There are 13 volunteers, 8 teachers, and 5 students. How many ways can the principal choose a 4-person committee that has at least 1 teacher? So there's 8 teachers and 5 students. And we need a 4-person team. So there's going to be 4 different conditions. If there's 1 teacher, 2 teachers, 3 teachers, or 4 teachers, you could have a 4-person committee. The 4-teacher one is the easiest one to do, but let's go through each one. So each committee is made up of teachers and students. So we're going to multiply by the condition of the teacher and the student. If there is 1 teacher, that means you have to pick, If there is 1 teacher, that means we need to pick 3 students. If there's 2 teachers, we need 2 students. If there's 3 teachers, we need 1 student. And if there is 4 teachers, we need 0 students. We know that N for the teacher is 8, and N for the student is 5. So for this one, our R is going to be 1. We're choosing 1 teacher. For this one, our R will be 3. For 2 teachers, our R is 2. We're choosing 2 teachers, and we're choosing 2 students. We're choosing 3 teachers here, and we're choosing 1 student here, and we're choosing 4 teachers here, and 0 students here. So we have all of our N's, they're the same throughout, and we have all of our hours. Our R's. That's a hard one for me. So we're going to fill in our formulas for each of these. So for this we have 8 teachers choosing 1. For this we have 5 students choosing 3. So that is our first section. For this one we have 8 teachers choosing 2, 5 teachers choosing 2. 8 teachers choosing 3, 5 students choosing 1. And the last one, we have 8 teachers choosing 4 and 5 students choosing none. So to fully write out this formula, we have 8C1 times 5C3. And we're going to add each of the conditions together. 8C2 times 5C2 plus 8C3 times 5C1 plus 8C4 times 5C0. So we have these all in. If you type these into your calculators, you get 8 times 10 plus 28 times 10 plus 56 times 10, 5 plus 70 times 1, which is 80 plus 280 plus 280 plus 70 for a grand total of 710 options. So there's 710 options if the teacher chooses at least one teacher to be on the team.